Hi everyone, Titus here for part 3 of our Chaff grenade series, and in this video we'll focus on creating the post-process effect that simulates an electronic failure for our heads-up display. Alright, let's not waste any time, jump right into it. Alright, in the last video we created the blueprint to actually toss out the grenade, so this one will just focus mainly on the post-process effect. If you want to modify any post-process via code, you need a parameter collection. So we're going to come to our materials folder, we'll right click, go into materials, and we'll create what's called a material parameter collection. I'm going to call it PC underscore dataset, or whatever you guys want to name it, doesn't matter. We'll double click to open it up. We're going to add a singular scalar parameter. We can expand out our index, and I'm going to rename scalar to alpha, because this value is essentially going to be controlling an alpha value, so it just makes it easier for me to reference it later in code. And then I'll save that, and that is literally it. We're done with the parameter collection. So now we can actually come back to our folder, and we are going to have to modify some of our blueprints real quick. If you remember, we created the chaff grenade, which when it's spawned, it creates this collider. And when this collider spawned, it does a trigger zone, and it detects if if an object or a player interacts or overlaps with it. If it does, it prints out this message that says chaffed. If it doesn't, it prints out a message that says it's missed. We want to replace this with actual code, or prep the code, so we can delete these two print strings. We can come into our first person character, go into the event graph, and we can right click in a blank space and do what's called a custom event, or add custom event. We'll call this one chaff underscore start, and then we'll right click and do custom event again. And this one will just be chaff underscore stop. Now, depending on the implementation of your mechanics, you may want to alter this code. So the way I'm going to do it on this project is it's going to spawn out the chaff. If the player interacts or gets hit by it, they get hit with a penalty. They cannot be penalized while they're already in a penalty. So, I'm going to slow their movement, I'm going to mess with their screen, but I'm not going to reset that effect if they get hit again if they're already in it. So I'm basically going to control that dynamically through code. You may want a project where you can chaff a person multiple times and they can't get out of it. That all comes down to game mechanics. So just be aware of how I'm doing it. You may need to change your actual implementation. So we'll go ahead and compile and save, and then we're pretty much done here. And then under the collider, I can drag off the first person character and run a search for the chaff start, and just replace those print strings with chaff start. And then the code's pretty much set up. So that's pretty much it for the collider, the grenade, and we'll do the first person character probably in the next video. So let's go back and focus on the post-process effect. We've created the parameter collection. You just right click and we'll create an actual material, and we'll call it post-process or pp underscore chaff. We can double click, open up the actual object. We're going to switch the material domain from surface to actual post-process. And then I like to scroll down to the very bottom and change blendable location from after tone mapping to before tone mapping. And that should help with some anti-aliasing issues, but is completely optional. Starting off with this effect, I'm going to right click and run a search for a scene texture. By default, scene textures come in as scene colors, so we're going to change it from scene color to a post-process input 0. I'm then going to come out the color, and I'm going to search for mask and choose component mask. I'm going to select the RGB, which you can either expand it and check the boxes here, or you can just select it and check the boxes in the details panel on the left. Then I'm going to right click and search for a blend hard light, I'm going to hook this up into the base, and then I'm going to do a color search. It's going to be a constant 3 vector. You can see it's labeled as a shortcut 3. So we can just click 3, left click in the graph, and then you have basically a way to do color. I'm going to right click on this and convert it to a parameter, and I'm going to call it color. And then I'm going to double click here, and I'm going to choose maybe something different, maybe something green, something like that maybe. And then I'm going to hook up the RGB channel into the blend, and then from here I can actually hook this up into the emissive color, and you can see we have the effect starting to take shape. So with this, I'm just going to select these nodes. I'm going to press C to comment, and we'll call it color of screen with blend. And then I'm going to drag this back a bit. That's the first part. Second part is going to be the scan lines. So I want to create some lines that actually will eventually move. So the way we can do that is we can just right click and do a screen position. And then I can right click and do a breakout float to components. I'm going to hook up my UV viewport into the float. And then I'm going to hold S and left click, and that's going to give me a scalar parameter, and I'm going to title it or name it lines, just because this is going to be the number of lines that are actually showing on the screen. Put these close together. I'm going to then press M on my keyboard and left click, and that'll give me a multiply node. I'm then going to hook up the green channel into A, and then the lines output pin into the B channel. And then I'm going to right click and search for a frac node. I'll hook up my multiply into my frac node, and in order to get it into this, we have to just press M, click in the screen, get a multiply. We'll hook the multiply in there, frac node in there, and then we'll replace the emissive color here. Now, right now the lines are set at 0. I'm going to change that to 2. And then you can start to see we actually have a break in the screen, or the effect. So if you were to change the number of lines, do like 10 or 50, you can see you can get a lot of different interesting effects. But I'll switch it back to 2 for now, and I'm going to select everything, comment this out, and I'm going to call it scan lines. You can call it whatever you want though. Now, we want the lines to move. The way I can achieve that is I can right click and search for a time node. I can then do a simple multiply node, so M click, add that into A, and then just like before, we're going to hold S, left click, and we have a scalar value, and the scalar value I'm going to call speed. You can call it whatever you want though. I'll hook this up into the B channel, and then from here, this is actually the entirety of the movement code, so I can actually just comment this as move scan lines. Make it simple. In order to make it work with the scan lines, we'll want to do an add node, so press A, left click, and then we can hook this up into the B channel. We can hook the green channel into the A, and then come off the add and replace the A over here. Now you'll notice it doesn't move, but that's because our speed's set to 0. So if I do something real small like a 0.1, you can see that the screen starts to move. So you actually have the basis of the beginning of your effect. And then you can, from here play with your values. Like we had 10 or 50, or maybe if you increase the speed, you go 1, 50. Well, I guess 50 is too fast. So 5. Although if you increase or decrease the number of lines, that'll probably change. And you can get all sorts of interesting effects here. Right? So that's why I think a lot of people prefer post-process effects, is it's definitely a more complicated setup, but once you get it, you know, it's just some minor changes here and there, and you can get drastically different effects. So I think that's why people prefer it. But comment down below on why or why not you might use this. I'm going to set it back to the demo code that I showed. So I'm going to do 2 lines with a very slow speed of 0.1. Now, just to add a little extra effect, if you look at the perimeter, it's kind of like solid one color. So I'm going to maybe darken that. The way we can do that is through a texture coordinate or a texture sample. So control space, I'm going to scroll down to my engine content. If you don't see this folder, you can go to settings and make sure you have show engine content checked. You might also need show developer content as well. You can just match kind of what I have here. And then I'm going to run a search for textures. So I'll check that under my filters. And I forget what it's called. I think it's Gizmo something. So I'm just going to scroll through and see if I can find it. Gizmo texture, right there. So I can drag this into the graph editor, like so. If you notice, the color is white on the perimeter and dark in the middle. I want the inverse of that. So I want it to be darker and then lighter. So let's lighten this up to see if you can kind of see what I'm looking for. The way we can do that is we can drag off the RGB. Actually, no, I'm sorry. We're just going to be using the red channel. So we'll drag off the red channel and do 1-. That'll invert it. And then we're going to hold M, left click to get another multiply node. Hook this into A, hook this into B, and replace our emissive. And now watch the perimeter of your screen. So you get that nice subtle dark effect. Yeah, it's not much, but it's little things that they kind of add up. So I'm going to come here and darken this a bit. So you get something like that. And then I will comment this out as just our border color. Or maybe border, darken border, you know, whatever you want to name it, I guess. Doesn't matter. Okay, and then the last is the actual static effect. This is probably the most complicated part of it. The way we can achieve that is we can just right click and do a texture coordinate. So this one right here, it'll come in as text coordinate. And then I'm going to press P on my keyboard and left click to give myself a panner. And then I'll hook the coordinate in there. And then I need a normal map and a texture map. The ones I'm going to be using, I don't have any from the web, so I'm going to use more engine content. And I'll show you kind of how cool this system is, because I'm going to use things that don't really make sense for this effect, but I can still make them work. One is a water normal. So, let me see if I can find it. Okay, so I need the T_sky stars, so we can drag that one in. And then the water normal is this one, water_n. So I need that one. So these effects have really no business being in this one, but you can just demonstrate how versatile this system is. You can see how I can make use of it. So I'm going to hook in the panner to the UV, and then I'm going to come off the RGB into a component mask. So search mask, choose component. I am going to leave the RG only. I'm going to leave the blue channel alone. And then I'm going to come into a multiply node, hook up into the A, and then for the multiply value, I'm going to do a very small 0.01. And then what we can do is come into an add node, so hold A, left click. I'm going to drag into the A channel, drag this into the B channel, and then we're just going to rinse and repeat into the second texture with another panner. So hold P, left click, hook into the texture node, and then hook into our UVs here. And now all we need to do is do an add node to get into this. So we can press A, left click, grab that, And then we'll drag this into the B channel. We'll drag this into the A channel. And then we will replace the emissive color. And then you have this funky looking effect here that's not very good, but we'll clean it up here in just a second. So I'm gonna drag this back just a bit. Okay. So first things first, panners are used for movement. So we have the first panner into the water normal. So I can come into here and do a real small value in the X and Y, like maybe do a 0.1, and you can kind of see this little flicker, which looks pretty cool. I don't think you'll see much of a difference if I add it in the Y. I do like a 0.1, yeah, a little bit. You can do something crazy. I think too much, and it doesn't work. So I think a real low value of like 0.1, and you get this kind of nice effect here, just on the water normal. Now, if you want to move the stars, same thing. You can come to the panner, and in the X and the Y, you can give some values. So I did 0.5. Then you can see the effect kind of goes from right to left, and then I can, speed it up. I can do 1 or 10, or 100 or 1,000, something real weird. So you can get a lot of interesting effects just from that. But let's leave it at 0.5. And then the Y is just going to do the same thing, but obviously in the Y direction. So you get some interesting effects there. But I'm going to leave that at 0, just move it aside. Now, obviously, the stars are a bad use for stat. Well, I mean, they're not bad. It kind of creates, like old school tube televisions. But what's cool is you can, in the texture coordinate, you can modify the tiling. So if I set the U tiling to 0, you notice it looks a lot more realistic, like the static effect that you saw in the demo. And that's just using, stars. So obviously this isn't a great texture map for this, but you can make it work just by, modifying a few parameters. And then instead of the horizontal, if you didn't want the horizontal, you wanted vertical, leave the U tiling to 1, set the V tiling to 0, and then you have your vertical lines. So you can get a lot of cool effects just from that. But I'm going to go with what I had in the demo. So I'll set V tiling to 1, U tiling to 0. And then I'm going to select everything, comment it out. And we'll call this the static effect. All right. Now the other part of this is if we were to go into the first person character, and there's a few ways we could do it, right? You can add like a post-process volume to your actual level, and then you can expand that out into a portion of your level, or include the whole level, or make it unbound, and then the effect is triggered anytime they're in that volume. Because we're doing a chaff effect and you don't know where they're going to be chaffed, it makes more sense to add it to the player character. So we can come in to our components view, do an add, search for a post-process, and then I'm just going to title it pp_chaff. With chaff selected, we can come down here, and under rendering features, you have post-process materials. You can add an element, hit choose, asset reference, hit the drop down, and we called it pp_chaff. Now, if you scroll down, unbound, make sure that's checked. That'll do the effect everywhere. If you don't, then you have to scale up your little cube to be a particular size, and the effect will only trigger when they're in that volume. So if you're doing it on the player, it doesn't really make sense, so you might as well just check unbound. If you wanted it to only affect a certain part of the map, you shouldn't be doing it this way. You should be doing it by adding a volume in the scene and doing it that way. But, either way. So then we can come to our chaff effect and hit save. Let's hit play, and then you notice the effect is always active, which is not what we want, right? So we need a way to be able to control that via code, and that is leveraging our PC dataset parameter collection. So to be able to do that, we can just simply right-click in the scene and do a scene texture. And then from the scene texture, we'll come off the color and we'll do a component mask. We'll do the red, green, blue. And then we're going to press L, left click, add a lerp node, hook the A channel in there. And then we're going to right click and do a search for something called a collection parameter, like that. As you may have already guessed, when we select the collection parameter, we can hit the collection and of course use our PC dataset or whatever you named it. And then the parameter value we're going to be modifying is alpha, or whatever you named your parameter name. So we can hook this into the alpha, and then we can hook this into the B channel, and then replace the emissive color here, and the effect's going to go away. Which makes sense, right? Because our data set is initialized at a value of 0. At a value of 1, it'll do the actual scene texture. Oops, actually we have an error. Oh, sorry. When you add your scene texture in here, it defaults to scene color. We need to change that to post-process input 0. And then save. So now when we play, the effect isn't going to be active. And we can basically trigger the effect through code, which will modify this default value from 0 to 1 or some in between. And now if I set it to 1 manually and hit play, you can see the effect is active. And set it back to 0, save. And now the effect's not active. So that's basically just laying the foundation. So for later, when we set up the blueprint code in the first-person player, it'll actually trigger the effect on and off. We'll do dynamically. So, all right, everyone, we'll cut it here to keep it short. In the next video, we'll add the code to the actual first-person character blueprint, so we can update that parameter collection, and then you'll be able to see the the heads-up display, get that static dynamically, basically on and off. But as always, thanks for watching. Consider subscribing, and we'll see you on the next one.